All right, guys, welcome back. So here's another set of questions that we want to be able to talk about. So let's see what we've got here. Calculate the enthalpy of formation, delta H naught F, for benzene, C6H6 liquid, given that the heats of formation of CO2 gas and H2O liquid are negative 393.5 kilojoules and negative 285.8 kilojoules, respectively, and that the heat of combustion of C6H6 liquid is negative 3267.7 kilojoules. Now it says carry out the following steps. So there are steps here. We're going to balance thermochemical equation that defines the enthalpy of formation of benzene. So enthalpy of formation, I want to form 1 mole of benzene. So that's C6H6 liquid. And I want to form that from its constituent components, meaning carbon in the solid form, and then H2 gas. Now I'm going to need 6 of those and 3 of those to make that work. So let me make that a little bit more readable, plus 3H2 gas. Okay, so that's the heat of formation for benzene. We want to write the balanced thermochemical equation for the combustion of benzene, C6H6 liquid. So C6H6 liquid plus O2. So when we combust something, we react it with O2, and that gives us CO2 gas plus H2O liquid. Okay, I have 6 carbons over here, so I need to have 6 over here. And I have 6 hydrogens over here, so I need to have 3 H2Os to make the hydrogens work. Now, I know that I have 3 oxygens from this and 12 from this, so that's 15 that I need, but I have this too, so it's 15 over 2. That works. I could multiply the whole thing by 2 to get rid of the 15 over 2, but I'm going to leave it that way. Now, based on your answer to question 2, write an expression for the heat of combustion of benzene, delta H naught com, in terms of the enthalpies of formation of the reactions and products. Okay, well, all right. So I need a little more space. So what I'm going to do is I'm going to copy these right here. And actually, I didn't get everything, so I'm going to copy those right there. And I move them over to this piece of paper that I got for myself. Oh, cool. And I'm going to just put them right there for now. And then I will put the heat of formation equation right here. And then I will move this combustion there. And then I have this equation right here. And then it says that I'm supposed to have enthalpies of formations of the reactions and products. Now, when we talk about enthalpies of formation of the reactions and products, we're talking about CO2, right? So I want to form CO2. That's my product. That's a gas. I need to form that, 1 mole of that, from its constituent components. So C, solid, plus O2, gas. And look at that, that's balanced. Oh, that's awesome. And I know what this amount here is. That's negative 393.5. Because I got that from the previous slide. I also need to make an H2O. So H2O liquid is made by adding half of an oxygen plus an H2, both of those are gases, and that's negative 285.5. Okay. Well, that's awesome. So I'm looking to do this, and I have all of this. This right here, these two here. So the first thing I'm going to do, I'm going to look at my desired equation. The C6H6 liquid needs to be a product. So I'm going to reverse this equation. Oh, and they also told me that the heat of combustion for this, so this reaction right here, is a negative 3, 2, 6, 6, no, 6, 7. 3267.7. Which is really what that says. It just doesn't look like it. Okay, so I'm going to reverse this. So when I reverse that, I end up with 6CO2 gas plus 3H2O liquid gives me C6H6 liquid plus 15 halves of O2. And of course, since I've reversed it, that's 3267.7, which is positive. Okay, awesome. So it gets me my C6H6 over here. Now, I also need to get rid of this H2O that's here. So I need to have H2 be one of the components. So I need to have 3H2 on my reactant side. So I have an H2 here. So I need to have 3 of those. So I'm going to multiply this equation by 3. So I'm going to end up with 3 halves of an O2 gas plus 3H2 gas going to give me 3H2O liquid. And of course I multiplied that by 3, so I need to take my negative 285.5 times 3. And that's negative 857.4. So now I have my 3H2 that I've accounted for. I have my C6H6 as a product. So I need to get my carbon in there. So I need carbon on my reactant side. So I can use this equation to get that. And I need to have 6 of them. So I'm going to multiply this whole thing by 6. So 6C solid plus 6O2 gas gives me 6CO2 gas. And I take that negative 393.5 and multiply that by 3. And negative 393.5 times 3. No, not times 3, times 6. Which gives me negative 2361. Okay, now let's see what happens if I try and add all this. I have 6 CO2 here. I have 6 CO2 there. So that's going to cancel. I have 3 H2O here, and I have 3 H2O there. So that's going to cancel. And I have a problem. Something's unbalanced. So what did I do? 6. Oh, I love it when you do this. All right, so I have 3 halves of an O2 here, and I have 15 halves of an O2 here. So I can cancel the 3 halves of the O2, and that leaves me with 12 over 2, which of course is 6, 6, and 6. So that leaves me with exactly what I'm looking for, 6C6. Plus 3H2 gas gives me C6H6 liquid. And of course, all I've done is add those 3 numbers that I've already manipulated together. So 3267.7 minus 857.4 minus 2361. And that gives me 49.3. Okay. So as long as my math is correct, that should be what I'm looking for. Okay. And again, forgetting that this is out here because it's running into this is not helpful, but that's why that caused me the hang up, because I couldn't find the other oxygens that I needed to make this work. Okay. So any questions about that? Hopefully not. So that was the last one on that page. I'm going to go ahead and stop at this point because, again, technical difficulties. I'm going to stop here and I'll be back shortly.